Hello everyone. So I'm Aniket Mukherjee. So today I'm one of the TA for NPTEL's via MMOC course for reinforcement learning, which has the code CA75, which is given by Professor Balraman Ravindran from IIT Madras. So today is actually a dry run for the tutorial sessions for the same course, reinforcement learning. So I'll be doing the same tutorial courses weekly. The date is Friday 6 to 7 p.m. And so today we will do some of the assignment questions which have been posted on NPTEL's SWAYAM module, which most of you guys might have had a look into. So I'll be solving all of the assignment questions. You guys might have already solved it, but I'm just giving the solution so that you can compare your answers with it. So yeah, so first let me introduce myself. I'm Aniket Mukherjee. So I'm doing PhD in Department of Electronic Systems Engineering in Indian Institute of Science, Bangalore. You have my email ID. So for any further communication regarding this. So yeah, so I'll get into the assignment questions. So first, the assignment question, we have a problem which states that if probability of A is equal to 0.5, probability of B is equal to 0.7, and probability of C is equal to 0.9, find the range of values of E of A union B given C. Okay, so this question, the week 0 assignment is all for your prerequisites. What all will be required in? Okay, zoom in a bit. Okay, is this fine? Okay, not everything is super clear. Okay. Yeah. Okay, so just tell me when to stop zooming. I think you can unmute yourself also. So there's no issue.
Yeah, I think we should do now.
Okay. So I'll go ahead and so the week 0 assignment is basically for your prerequisites which are required for reinforcement learning. So you'll have some questions on probability, you'll have some questions on linear algebra, some questions on set theory and stuff like that. Yeah. So I'll be solving the first question. So first question you have, I'll state it again. So probability of A is equal to 0.5, probability of B is equal to 0.7, probability of C is equal to 0.9, which is given. So we need to find the range for probability of A union B given C. So first, okay, let me write the. Okay, so I think most of you will know that probability of conditional probability can be written as probability of A union B intersection C by probability of C. So now if I treat A union B as an element A1, I can write probability of A union B intersection C as probability of A union B plus probability of C minus probability of A union B union C. So here I have an assumption because only A, B and C are given to me, nothing else is given to me. So I assume that my A, B and C are the whole, my universal set. So probability of A union B union C is 1. Okay. So then I can further write probability of A union B as probability of A plus probability of B minus probability of A intersection. I think this formula most of you might be familiar with. This is a basic probability formula. So I get this. Now shuffling, I get probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of A union B union C. The values for probability of A is given as 0.5, probability of B is 0.7, probability of C is 0.9. So substituting those, I get 0.5 plus 0.7 plus 0.9 minus probability of A intersection B minus 1. So calculating this, I get 1.1 minus probability of A intersection B. So now the thing which I require, the conditional probability of A union B given C, is equal to 1.1 minus probability of A intersection B by probability of C. Now I need to find the bounds on probability of A union B given C. So I need to find the maximum value that probability of A union B given C can achieve and the minimum value that probability of A union B given C can achieve. So the probability of A union B given C, the maximum value that it can achieve depends on, okay, so we also have probability of C as 0.9, so I'll replace this with 0.9. So maximum value of probability of A union B given C is achieved when probability of A intersection B is minimum. So just normal probabilities values can range from 0 to 1. So let me assume that probability of A intersection B is minimum. So let me assume that probability of A intersection B is 0. This is just an assumption. So if I assume that, then my value for probability of A intersection B goes something which is greater than or equal to, which is greater than 1. But probabilities, since probability of A, conditional probability also is a probability and it should also be bounded by 1. So the maximum value that probability of A union B given C can achieve is 1. Okay, so next I know that I need to find the maximum value that probability of A intersection B can achieve. Maximum value that probability of A intersection B can achieve, so that I can find the minimum value of probability of A union B given C. So I know that A intersection B is a subset of A, and I also know that A intersection B is a subset of B. So probability has a law of monotonicity. So it says that if E is subset of B, then probability A is less than probability B. So using that, I get probability of A intersection B is less than or equal to probability of A. The probability of A intersection B is also less than or equal to probability of B. But we are given that probability of A intersection B is less than or equal to probability of A, and we know the order between the probabilities of A and B, because probability of A is given as 0.5, probability of B is given as 0.7. So probability of A intersection B is less than or equal to probability of A is less than or equal to probability of A. Okay, so I can always assume that the maximum value that probability of A intersection B can achieve is probability of probability of A, which is 0.5. So if I substitute 0.5 in the place of probability of A intersection B, I get the minimum value as by 0.9, which is 0.6 by 0.9, which is 2 by 3. So the maximum value that probability of A union B given C can achieve is 1. And the minimum value that probability of A union B given C can achieve is 0.2 by 3. So my conditional probability of A union B given C lies between, so probability of A, okay, let me write that. So probability of A union B given C belongs to the region 2 by 3, 1. As you can see, it is the second option. So this is how you, like, this is also, this would come up in many domains of, like this one of the basic questions which comes up in probability, but like, yeah, so this is how you need to try and find out the bounds for conditional probability given some events and probability of some events. Okay, so I think this is clear, so I'll just move on to the next question. So next question is a fairly simple question because okay, so what does it ask? Find the variance of the random variable x, and distribution of the random variable is given, and even the support, the values that the random variable could take is also given. So now I need to find the variance. So okay, so I hope that everyone knows that. Okay, so I have random variable x. This is my random variable. So variance of x is equal to expectation of x square minus expectation of x whole square. This is the formula for variance. So I need to find expectation of x and expectation of x square. So first let us find expectation of x square. So expectation of x square, you get b integral 0 to 1, because the support is 1, x square into 4x square plus 1 minus 4x dx. So expanding it, you get 0 to 1, 4x power 4 plus x square minus 4x square. Solving this integral, you'll get this value to be equal to 2 by 5. Okay. So next I'm going to calculate the expectation of x. So again same, 0 to 1, x, 4x square. But now since you're calculating the expectation of x, not x square, so you'll put x and then the density function, plus 1 minus 4x into dx is equal to 3 into integral 0 to 1, 4x cube plus x minus 4x square dx. So yeah, so dx. So this value turns out to be 1 by 2. Now putting it in the variance of x equation, we get 2 by 5 minus 1 by 4, 1 by 2 whole square. So you get this to be 3 by 20. Yeah, so this is just a calculation step for this is just a calculation step. So this is just a calculation problem. So if you know the formula for the variance of a random variable, then you can calculate the variance by calculating the expectations. So the answer for this is 3 by 20. Okay. So I hope this is also clear. So next I'm going to third problem. So third problem is fairly simple problem because it asks you like what are the, it depends on the properties of when x and y are independent random variables. So I'll just give you a definition of when x and y are independent. So x and y are two random variables. If x and y are independent, then we can write that the joint distribution between them could be productified. The joint distribution where fx is a joint distribution of x and fy is a joint distribution of x is a marginal distribution of x, and fy is the density function of y. So density function of y. Then if it productifies, then you can say that x and y are independent. That is an if and only if statement. So that's fine. So let's check the options now. So the first option, the expectation productifies. Since the PD productifies, the expectation of also productifies. So which of the following is false? So this is not my option. The first one is not my option. Next you have, since they are independent, the covariance of x and y also goes to 0. That is also true. So this is also not false. And you can check out that if variance of x plus y, also you will get variance of x plus variance of y. So this is not true. So the last option, you get expectation of y given x is equal to expectation of y if x and y are independent. But here it is given expectation of y given x is equal to expectation of x, which is clearly false. So fourth option is the correct option. Okay. So in this question, we are just checking all the properties of independence random variables. You can just check the options one by one and find out which of them is false. Okay. So next, so next I'm going to do the question. So here, fourth question they have asked, like, which of the following is not a valid norm function? So, so first let us define what a norm function is. So norm function, you have some properties the function needs to satisfy. So one of them is it needs to satisfy the triangle inequality. So what do you mean when, so I say f is a function which is norm as given in the option. So what do you mean when I say it's triangle inequality? So if I put x plus y should be less than or equal to f of x plus f of y. Yeah. The next is homogeneity. So f of x should be equal to modulus of f of x. So this is called as absolute homogeneity. It's fine, absolute homogeneity. So the third one is positive semi-definiteness. Positive definiteness, and it is only 0 when the entire element is 0. So if a function satisfies these three properties, then we call it as a norm. So yeah, so now what we'll do is we'll try to check all the properties for all the options that has been given there. So mainly I'll be checking the triangle inequality, because absolute homogeneity and positive definiteness, I think most of the functions there follow, because the second, third and fourth options have modulus in them, so no way of getting a negative number, so it will always be positive. The first one you have a square, so even if you have a negative element in the term, then it will become positive. So yeah, so we'll just check in the triangle inequality. So for the first option, so we have the function as x1 square, xi square. This is an Rd dimension, so x belongs to Rd. So here I need to write that x and y belong to Rd, and f is a function which maps from Rd to R, and here a belongs to R. So these are all the mathematical technicalities. Let's not go really deep into it, but I hope that you understand where this comes in. So if I have x and y both belong to Rd, then I know that summation of I equal to 1 to d xi square plus is equal to 1 to d yi square is less than or equal to, is greater than or equal to, root over summation I equal to 1 to d xi plus yi whole square. So since like you can prove this, or you can also have a intuition behind it. Since xis and ys can be negative, so this term could be something which is very less than the sum of two positive terms, the term which is inside the right hand side of the equation. So you know that this is always going to follow. So the first function follows the triangle. Similarly, we have the second one as summation. Summation xi. So similarly, if you have x comma y belong to the Rd space, from the properties of modulus function, you can write that summation xi plus summation yi greater than or equal to summation xi plus yi. This also something which follows. So we know that this also follows the triangle inequality. Okay. Then we have max, and yeah, so max of modulus of xi plus yi is less than or equal to max of mod xi plus max of mod yi. So this also follows. But when it comes to minimum, so what happens is min of mod xi plus yi is greater than or equal to min of mod xi plus min of mod yi. So yeah, so minimum is a function which does not satisfy the triangle inequality, and so it's not a norm function. So we have our answer, which is so if you can look up much more online sources which goes into very detail on the proofs for the triangle inequality sufficient conditions for these things, but due to time constraints I'm not going through all the proof. I'm just stating the statements that these follow the triangle inequality and what functions don't follow the triangle inequality. So, but the main thing that you need to take away from this is the properties of norm function, that norm should satisfy the triangle inequality, absolute homogeneity and positive determinants. If those three checks are done for the function, then that is a valid norm function. Okay. So next I have my next question. So fifth question is a question from linear algebra. So yeah, so let me read the question. So the following is false for a matrix M. So this is basically a theory question. So yeah, so this is basically a theory question. So let us look at the options. Trace of M is sum of its eigenvalues. That is something which you know to be true. Determinant of a matrix is also the product of its eigenvalues. That is also something you know which is to be true. Real eigenvalues of M are distinct. There could be matrices which have same eigenvalues, so that is false. Like that is the odd one out. So yeah, so real eigenvalues of M are need not be distinct. Yeah. Because yeah, need not be distinct. Real eigenvalues of M need not be distinct. You have matrices where the eigenvalues can be same values. So that is the answer. So and the last option, rank of M is number of non-zero eigenvalues. That is also true because rank of M gives you the non-zero eigenvalues. That is also a theory question. So this question is basically a theory question. So that is the answer for now. Okay. So let's go on to sixth question. So sixth question states that okay. So A be a square non-singular matrix with eigenvalue lambda 1 for eigenvector x, and B be square matrix with eigenvalue lambda 2 for the same eigenvector x. What is the corresponding eigenvalue for the matrix A inverse B power Ka for the eigenvector x? Okay, so first let's write down what has been given. Let's write down what has been given in the question. So first, first we know that A is a square non-singular matrix whose eigenvector is x with eigenvalue lambda 1 of x. This is the relation between the statement I have written as eigenvalue and eigenvector. Similarly, B is a square matrix whose eigenvector is same, the x, and but eigenvalue lambda 2. So this is the relation that has been given. Now now the question wants us to find what is the eigenvalue for the matrix. What is the eigenvalue for the matrix A inverse B power K for the eigenvector x. It wants us to find the eigenvector, eigenvalue for it. So this you can write as A inverse B power K into Ax. But since we know that Ax is lambda 1x, so I'm going to replace it with lambda 1x. Since lambda 1 is a constant, so you can change the place in which it multiplies. But if lambda 1 was not a constant, you can't flip like A into B. If A and B are matrices, A into B is not equal to B into A. It might be in some cases A and B equal to B into A, but it's not always true. But since lambda 1 is a constant, you can bring it out. So lambda 1 A inverse bk into x. This I can write as lambda 1 A inverse b power k into x. So here I'll use one of the property of eigenvalues which states that if bx is equal to lambda 2x, then one of the so if lambda 2 is an eigenvalue for b, then lambda 2 power k is an eigenvalue for b power k. So this property I'll use there. Since lambda 2 power k is an eigenvalue for b power k, I can write b power kx is equal to lambda 2 power kx. Yeah. Yeah, so this gives me, so I'm continuing from here. So this gives me lambda 1 A inverse lambda 2 power kx. So again here, since lambda 2 is a constant, I can bring it out, lambda 1 into lambda 2 power k A inverse x. Now since inverse x, here again I'll use a formula that if lambda 1 is eigenvalue of k, then 1 by lambda 1 is an eigenvalue of A inverse. So then I can write that A inverse x is equal to 1 by lambda 1 x. So I can write this as lambda 1 into lambda 2 power k into 1 by lambda 1 x. So which gives me lambda 2 power k x. So now finally what I get as a statement is A inverse b power k. A inverse b power k a x is equal to lambda 2 power k x. This is of the form where you have the matrix, the eigenvector and the eigenvalue. So the eigenvalue for the matrix A inverse b power k a is lambda 2 power k. So yeah, so second option is the right option. So this is the sixth question. So yeah, so this also depends on, this problem is also for the basic properties of linear algebra and eigenvalues and eigenvectors. So yeah, I hope this is clear. Okay, so next let us go to the seventh question. So seventh question, sorry. One question is given, let x1 and x2 be two independent random variables. So independent, and then let us with mean 1 and 4 respectively and variance 5 and 8. So what is the value of expectation of x1 minus x2 whole square? That is what he wants. So he wants to know the value of x1 minus x2 whole square. So expanding the interval, we get x1 square plus x2 square minus 2x1 x2. And we since expectation is a linear operator, expectation is linear operator. So if expectation of a plus, you have expectation of x plus y, you can write it as expectation of x plus expectation of y, where x and y are two random variables. So I'm using the linearity of the expectation property and splitting it up. Okay, so now here I'm going to use the statement that is given in the statement that is given in the question, that x1 and x2 are two independent random variables. So what I know is, if x1 and x2 are two independent random variables, then the expectation of the product of these random variables splits out. Like you can productify the expectation, and so you get expectation of x1 square plus expectation of x2 square minus 2 expectation of x1 expectation of x2. So now calculating expectation of x1 square. Since we know that variance of x1 is equal to expectation of x1 square minus expectation of x1 whole square, I can calculate, okay, so I know the variance, I know the expectation of x1 square, I need to calculate the expectation of x1 square. I know the expectation and I know the variance, I need to calculate the expectation of x1 square. So yeah, so expectation of x1 square is equal to this okay, so variance of x1, what is the variance? 5 plus expectation of x1 whole square, so it's 1, 6. Next, similarly I need to calculate expectation of x2 square, which comes out to be x1 plus expectation of x1 whole square. So variance of, sorry, this is x2 and x2. So variance of x2, the variance of x2 is given as 8. 8 plus expectation of x2 is 4. So 4 4s are 16. This is 22. No, 24. Okay. Then I have I need to calculate this term. So I know expectation of x1 is 1 and expectation of x2 is 4. So 2 into 4, 8. So I have 6. So yeah, so expectation of x1 minus x2 whole square is equal to 6 plus 24 minus 8. So this is 22. So yeah, so option 3 is the correct. So this is also a simple problem where you need to know the properties for expectation. One of the property is linearity, and then you also need to know that if two random variables are independent, then the expectation productifies out. So we have used that also. And then you also need to know the variance formula that we need to use to calculate the second moment of a random. So this is also a very simple question. I hope that you have been able to follow the solution and maybe you have tried to prepare. Okay, so let's go into the 8th question. So 8th question. So the 8th question here is given that you are playing a game in which you have to choose one bag containing colored balls out of 2. From the bag you selected, you randomly pick a ball depending on depending on the color of the ball, you get certain points. Bag 1 contains 5 red, 4 green and 4 yellow with 50, 25 and minus 30. Similarly, bag 2 contains 4 red, 7 green, 5 yellow with 30, 30 and minus 20 respectively. Now which bag do you choose to maximize the points? So here what you are trying to do is you are maximizing the points, but then you want to pick a bag which gives you the maximum number of points. But then once you have picked a bag, the ball you have selected is random. So you have no control over what ball you can select. You randomly pick a bag. You pick a ball from a bag that you have selected. So now you need to define a metric such that you can identify which bag gives you maximum points. So one of the metric is you could calculate expected points once you selected a bag. So suppose you have selected bag 1, then what are the expected points I can get from bag 1? Suppose you selected bag 2, what are the expected points you can get from bag 2? And then you make a decision using the expected points that you can make from those bags. And there is also an option which states that you can refrain from playing the game to showing 0 points. Now I'll just state why we have given that that point has been mentioned in the question. But first let us solve this one. So let me draw. So let me draw 2 bags. So this is bag 1 and this is bag 2. And I have 5 red, 4 green and 4 yellow ones with points 50, 25 and minus 30. In the second one I have 4 red, 7 green and 5 yellow with points 30, 30 and minus 20. So let's calculate the expected number of points from that you can get from bag 1. Expected points from bag 1. So you can pick 5, you can pick red. So there are 5 reds and the probability of picking a red is 5 by 30 minus 30. Yeah, 5 by 30. And if you pick a red, you get 50 points. So the probability of you getting 50 points is the probability of you picking red into the number of points plus. Okay, so next you pick green with probability 4 by 13 and you get 25 points. Similarly, the probability of picking yellow is 4 by 30, but you get minus 30 points. So I have put the minus here. So this comes out to be, I think, 250 plus 100 minus 120. 250 plus 100 minus 120, you get 230. So this is your expected points that you get if you pick bag 1. Okay, so now expected points from bag 2. Okay, so expected points from bag 2, in the same way you do, like what is the probability that you pick a red is 4. Okay, here you have 16, right? 16 years total into 30 plus 7 by 16 into 30 minus 20, sorry, then you have minus, okay, yeah, sorry, then you have minus 5 by 16 into 20. So I think this gives you 120, 210 minus 100, 210, 220, 230. This also gives you 230. So as you can see from these two, the expected number of points from bag 1 is more than expected number of points you can get from bag 2. So here we have expected points from bag 1 is greater than expected number of points from bag 2. So the most probabilistically correct answer is you choose bag 1, because you have a higher expectation of getting more number of points if you choose bag 1 than bag 2. Okay, so now coming back to the question, they have given that you can refrain from playing the game to stay at 0 points. So what does this imply? So since you have, as you can see that there are negative points for choosing a ball, it could so happen that when you calculate the expectation from both the bags, you are in negative. Like you can change the number of points, change the game such that if you calculated the expected points that I get from bag 1, you could be negative. If you calculate the expected points from bag 2, you could go to negative. So in that case, why would you try to pick a bag and go to negative points when you're better off staying in 0 points? So that is the case when you choose the option do not play the game. But that is not the question. Now the question is which bag you choose, and you also have an option of refraining from choosing a bag. So the case where you refrain to choose a bag is when you get the expected points from both the bags is negative. Then you refrain to choose a bag. If both the expectations are same but positive, then it doesn't matter which bag you choose because expected rewards are same. So but in this question, since we have got that expected rewards from bag 1 is greater than expected rewards from bag 2, so I'm going to choose bag 1. So for the 8th question, that is your answer. So you need to choose bag 1, which gives you more points. So yeah, I hope that is also clear. So okay. So next, yeah, this is a fairly simple question, I think, the 9th one. Okay, so 9th one, it's given that a stick of length L is broken in 2 points. L is broken into 2 at a point chosen uniformly random on the stick. What is the average length of the smaller piece? So you have you have a stick which is of length L. So now you randomly choose a point. You want to know the average length of the smallest piece. So the smaller piece will always be less than half of the stick, because so let the length of the smaller piece be SL, which is a random variable. So now SL is between 0, L by 2. Because if SL is more than L by 2, then it is no longer the smaller stick, because you'll have a stick which is larger. So now SL is a random variable, and then we know that it is uniformly, the point is chosen uniformly random. So SL is also uniformly random. So now to find the mean expected value, we know that if it is a uniformly, so if x is a uniformly random variable with a, b, then the expectation of x is given by b minus a by 2. Similarly, I'll apply the expected length of L by 2 minus 0 by 2, which gives L by 2.
Wait, b plus a by 2.
No, minus, no. Hello?
Okay, so say you're uniform between 1 and 2.
I'm uniform between 1 and 2.
Mean will be 1.5, no?
Yeah, so, okay, 2 plus 1. Yeah, sorry. My bad. So this is b plus a, L by 2 plus 0. Yeah, but the answer still is, yeah, sorry, my bad, my bad.
Yeah.
Thanks for correcting, thanks for correcting. Okay, yeah, but the answer remains L by 4. So yeah, this is also a easy question. Yeah, so next. Yeah, so this is the last question for this week's tutorial. So yeah, so it's given, let A be a positive matrix. V and W are orthogonal eigenvectors of A transpose A. Which of the following is true? So yeah, so first let's see what orthogonal vectors mean. So V and W are orthogonal if the inner product of them is 0. Yeah, so are orthogonal. So now it's given that V and W are the eigenvectors of A transpose A. Yeah, V and W are the eigenvectors of A transpose A. So I can write, so I'll write the properties later. So I need to show that AB and AW are orthogonal. So I have 4 options. Let us go through all the 4 options and see which of those make sense. So the first option is AB and AW are orthogonal. So okay, so he wants to say that AB and AW are orthogonal. So then I'll check the inner product, AB whole transpose AW. This is what I want to check. If this becomes 0, then AB and AW are orthogonal. So this I can write as V transpose A transpose AW. Okay. So now, okay, since W is an eigenvector of A transpose A, I can write A transpose AW is equal to lambda W. There exists some eigenvalue for the eigenvector W, which is lambda W W, like lambda W, the substrate W into W. So I can write it as V transpose lambda W W. Now, yeah, lambda W again being a real number, so I can bring it outside and V transpose W. But in the question it is given that V and W are orthogonal. So this is 0. That means the whole thing is 0. So we are done. So like the inner product of AW and AB gives 0. So which implies that AB and AW are orthogonal. So this both implication. Similarly, so I have shown that AB and AW are orthogonal. So this is the first option. You can check the remainings. The second option says is AB and AW are not orthogonal. That's not true since you have just shown that they are orthogonal. Similarly, you can check all the options, but since we have gotten our option that AB and AW are orthogonal, so that is it. So I hope yeah. So this completes the tutorial section for the week 0 dry run of this case. So I hope everything is good. If you have any doubts, you can please ask. Next, I think we'll be meeting on this Friday at 6 to 7 p.m. for the week 1 practice questions for reinforcement.
I think question 1, the assumption that A union B union C is equal to 1, probability of A union B union C is equal to 1 is not necessary. I think you can start off by using the bound that A union, probability of A union B union C is bounded above by 1, and use that in again.
Yeah. Okay, okay, so you want to
So in
put
that
one more bound here, I guess, like.
the fourth equality sign that is there, that will I think just become a greater than or equal to sign.
Okay,
Everything else remains the same.
so yeah, so you want me, okay, so this would, okay,
Yeah,
just use the upper bound for probability of,
exactly.
yeah,
Because you know that we don't have any
we
more
don't have
information.
any more information. Yeah, but like I don't think making this assumption also hurts, because like
Yep.
no other event is given to you. Like all the events that's
True.
given to you is A, B, and C. So for you, that would be the universal set. Like
But yeah, I mean,
yeah,
yes,
yeah. But I think this doesn't change because the bounds remain still the same, right?
everything is same. Yeah, yeah. Yeah, this will give you your lower bound. Upper bound, you would have to, depending on the options, there's only one that's.
One that's,
And
yeah.
otherwise, you get sandwiched and you get an equality and not an inequality.
Yeah. But I think the upper bound, if it is like you're since you're exceeding one anyhow for the minimum case, so
Oh,
you can design one event, one intersection probability such that this thing goes to one, and you have an equality there also. So
yeah.
any more doubts?
Oh, yes, Aniket. The last, wait, is this still being recorded?
Yeah, yeah,
Will this be, like, is someone going to watch this recording?
yes.
Okay. No further questions.
But like all the solutions were correct, na? Like it was okay. It was fine.
Yeah, yeah, no problem there. Only the last thing, you assume the inner product translates to a transpose. I think the inner product the same result you can come, same conclusion you can reach in a more general sense, but that's okay. That's not a big deal.
Yeah, but I think this is fine, right? Because orthogonal, like, yeah, I get your point, but this is the I think one of the
Yeah, yeah.
simplest ways. Yeah.
This is good enough because if you're going to go that route, then you would have to also like
Huh,
list out the properties of norms and normed
huh,
spaces and
huh,
all that,
huh,
which
huh.
I think is not necessary. It's not
Huh,
adding
huh.
to the.
Yeah, yeah. Okay, I'll stop recording.